Yes.
Great. Hello, everyone. Welcome to this live event. My name is Umair from Microsoft, and I'm here to introduce you to the Teaching with Data Science live event, hosted by Bit Project. Thank you again for attending, and we're going to get started now. I'd like to introduce you first to the platform that you'll be using. You are on Microsoft Teams, and let's go over quickly how you use the live event controls. You'll see the video right here on your screen. Underneath, you can play, pause, and change your volume. On the right of that, you can adjust the quality and translate the captions into 6 different languages. You'll be able to ask Q&A during the entire event. Just type your question, enter it, and you can post it anonymously. We'll have the moderators answer your questions during the event and during the Q&A for each speaker. Please go ahead and take a picture of the screen, as you can leave the Bit Project team feedback after the event is over. So I'll give you a moment to take a picture of the screen. All right. Well, thank you so much for attending, and we're going to go ahead and get started with Bit Project. All right, Stephen.
Hi, can you hear me?
Yes, we can.
Is my screen, can someone send it live?
Yeah, you are live.
Perfect. Awesome. Hi, everybody. Thank you for coming to our webinar. Our main focus is essentially allowing the professors who are attending, as well as students, to gain understanding of how professors can be teaching with data science within the social sciences. We will be starting right now, kind of, just in case you want to follow along, we have a public access link for the Google Slides. So this is just a very small, short link of the bit.ly. Feel free to paste this in. I'll give you guys about 30 seconds. You guys need to paste it into your browser to also look at Google Slides. Cool. I think should be okay. So as a little kind of introduction of what our organization is, we are a Bit Project. We are the student organization that is holding this webinar. Oops. Those are our little logos. Our president is very proud of them, so I want to emphasize how adorable they are. So a little bit about Bit Project. So we are an intercampus college student organization. So we have students from really every camp, or like a lot of different campuses across the state and the nation. And our goal is to work together to create eventually a global technology community. And what we do is we work with industry partners to develop and make technical education accessible. And that is done through either workshops back when things were not remote. And now it is done with webinars and as well as other events we'll be holding in the future. So although we are a seemingly technology or like computer science club, we actually have offerings for students kind of in every different discipline, including content developers who are interested in marketing, or project managers who are just interested in analytical thinking. If your students are interested in this, or students who are watching this is interested, there is a join link on the bottom, bitproject.org/join, and you can kind of see the different positions to kind of how you can get involved with Bit Project. So today we will be having a few speakers ranging from students, professors, industry professionals, but we'll be starting with our president, Daniel Kim. He'll be kind of going over a little bit about how Bit Project has been involved with data science and kind of illustrate how the value of data science has really emphasized the different concepts within social sciences, as all the other speakers will also follow up with. But yeah, now we're going to be starting with Daniel. Daniel, you're on mute.
Can Sorry about the technical difficulty. So hi everyone, my name is Daniel. I am the president of Bit Project. And today I want to talk about the initiatives that Bit Project is taking to incorporate data science and data science education to those who may not traditionally get access to those types of technical education, and what Bit Project is doing to kind of help students who are interested in data science but not be in a data science major to kind of access and be competent in those skills. So a couple months ago, there was a big problem that I saw with a lot of my friends who were studying social sciences. That was that most students pursuing majors in the social sciences weren't getting enough experience to go into research. So when they wanted to email some professors to get into their labs or do some actual undergraduate research to get into grad school, the problem was that they didn't have the skills, the technical skills, to be able to effectively contribute to their professors' research and their PI's research. So what I did, in addition to my friends at Bit Project, was that we came up with a 4-week bootcamp for social sciences students to learn basic data science skills to solve a social science question, hopefully allowing them to gain the skills needed to get an internship or a research position at our university. And it was a very big success. And let me tell you how we did it and what we learned during this process. So we developed a 4-week timeline because it was a very condensed version of a boot camp on how we taught students how to operate basic Python in order to analyze data to support hypotheses in the social sciences. So the first week, it was a very simple week where we got to know each other. We got to introduce students to data science. So we introduced what data frames were. And we also started having students directly importing and manipulating very basic data sets that we found online. So week 1 was very simple. Week 2, it got slightly more complicated with cleaning and manipulating data. So we actually had students importing more complex data. So we had students work with the Twitter API. Suhem really helped, who's a speaker who's going to be speaking later on this process, where we had students directly access the Twitter API to gain data from a real life source and how to filter and manipulate that data. Week 3, we introduced very popular Python data science frameworks like scikit-learn, and to get students familiar with the idea of using libraries in Python. And week 4, we had students work with a social sciences professor at UC Davis to come up with a hypothesis that they could solve using data science. So I want to just showcase a couple of student projects that came out of this 4-week bootcamp. So a student actually analyzed the sentiment of customer support Twitter channels for food delivery apps. So using scikit-learn and pandas and the Twitter API, students analyzed the sentiment of the replies and tags, the tweets tagging these support Twitter channels for various companies like Uber Eats, Seamless, Grubhub, and DoorDash to figure out how consumers were reacting or interacting with a particular company in the food delivery business. That was an example of a project that incorporated many facets of social science. That's sentiment analysis, as well as a customer and company relationships. So that was a really interesting project that a couple of students came up with. Another really cool project that a student did was analyzing reactions to the Democratic debates. So as we all know, in the political climate, especially when this was going on, when the bootcamp was going on, the Democratic debates was a chance for students to access Twitter data from a real event that was happening. So what students did was they accessed the Twitter API to access tweets that were tweeted during or right after a Democratic debate, and using the pandas and scikit-learn libraries, they actually determined the sentiment of the tweets using various hashtags that were related to the actual event, and used that data to analyze the political sentiments towards the candidates from various users. So that was a really cool project as well. The third and final example I have for student projects in this bootcamp was the analysis of the relationship between customer sentiment and average ticket prices of airlines. So this project was slightly more complicated because it brought in more independent variables. So students, what they did was they used pandas and scikit-learn again to determine the sentiment of tweets that were mentioning particularly large airlines, and they actually compared that to the average ticket prices of particular airlines. So they wanted to see if there was a relationship or a correlation between ticket prices and customer service. And that was really awesome because they got to actually use techniques that they learned in their social sciences classes to extract kind of conclusions out of data science and correlations they saw in graphs, which I thought was really awesome. And the results were mixed, with some low-cost carriers like Southwest getting higher satisfaction than legacy carriers whose average ticket prices were much higher. But anyways, those were kind of the projects that our students worked on that incorporated real-life data sets to help them get internship and research positions in the social sciences. So here are a couple of findings that we as we were conducting this webinar, our boot camp. So practical equals good. Sorry for the bad grammar. But we found that students learn best when they can apply the skills they learn directly into their interests. So trying to incorporate real life data into interactive tutorials that have something to do with the students' research interests or their interests in general really kind of increases attention span and kind of interactivity for the student. So every single tutorial that we did for our boot camp was using real life data sets we found on Kaggle or other open source sources. So we highly suggest that when professors or teachers try to teach data science, they try to make it as relatable to the student as possible to increase retention. Another thing that we found were really, really helpful were step-by-step tutorials. So instead of just having lectures, having step-by-step tutorials to teach particular and abstract concepts provide students with different learning styles, another way to absorb like technical skills. We found that it helps a lot when you're trying to teach technical skills, especially to people who may have varying experiences and varying backgrounds, like new skills. So it's really helpful to have step-by-step tutorials. And the final kind of tip that shoot, sorry about that. I think I over-clicked. And the final thing we want to talk about is how, as BIT Project, we can help professors and teachers grow their data science programs. So we'd love to work with you, especially if you're a professor or a student org, to bring data science into students who aren't getting access to data science education. So if you're interested in working with BIT Project to collaborate on a data science module or help implement a system for students to teach them key data science skills, please contact me. So my email is very simple to remember. It's daniel@ucdavis.edu, or reach out at info@bitproject.org for collaboration opportunities. So that is pretty much my spiel. Yeah. So will you consider providing the 4-week course online for us during summer? Right now, the 4-week course will probably not be offered this summer, but will probably be offered during fall. The reason is because as the organization is changing amidst COVID-19, we need to focus on basically getting our stuff right. So we're going to be, for the meantime, like focusing on webinars like these to reach a wider audience, and then we'll be focusing on things like the 4-week course. So that's kind of where we're at. How was the bootcamp funded? Actually, we didn't get this funded. We actually just as like a passion project amongst like us undergraduates. So to be honest, for professors, it might be a different story, but for us, what we did is that we got a bunch of students with varying experiences together in a room, and we actually came up with curriculum just as like a passion research project. So sadly, we didn't get any funding, but hopefully in the future, we can get funding. Steven, were there any other questions that
No, we will be sending now. Keeley will be speaking, and I should be going live right now, Daniel.
Awesome. Well, thank you everyone for coming to the, yeah. Thank you so much.
Thanks, Daniel, and thanks, Stephen. And hi, everyone. It's so great for you to be here, and it's great to be speaking here. It was awesome to be invited. My name is Keeley Takimoto. I am on staff at the UC Berkeley Data Science Education Program, and I'm here to talk about the Modules program, which I coordinate and I used to be an intern for. So my background is in cognition. That was what I did undergrad in. And I also studied instructional design. I worked for 4 years at Planned Parenthood as an instructional designer and staff training specialist. So I come from this background of taking something technical like reproductive health and breaking it down for a wide audience of people. And that's very similar to what the Modules program does. So what is a data science module? It is, in a nutshell, a short exploration of applied data science that gets embedded into an existing non-data science course, usually something in the social science or humanities. So this is maybe the introductory sociology course that you've been teaching for a while, or an ethnic studies seminar with a particular focus that you're interested in bringing a data science lens to. And the modules that we make are pretty short. It's maybe 1 to 3 lessons for most classes that can be deployed in a lab style setting, in a lecture style setting, or in 2020 in an online environment. And we try to gear them towards people who not only have never done coding or statistics before, but who potentially have actively avoided it, people that ran away from a stats class. We've had the pleasure of working with a wide variety of topics at this point, and this is just a small selection. So all of the materials that we make are open source and available to view, or in many cases, use for yourself online. I'll have the link to our repository with all of these notebooks at the end of the presentation. And this modules program was very much a grassroots effort. It came from students designed for students. So back in 2017, a group of undergrads took their foundational data science class, got really excited about the power of data science to bring a new lens to view the world and make conclusions and predictions. And they wanted to give that same aha moment to other students. So they started reaching out to professors, making materials, and it became a program with an official staff member. So this is very in line with the data science education program's core belief that any domain can be enriched by including this data science component. We are using big data to study Near Eastern studies or rhetoric, or even something like drama or theater. It also came from an accessibility and inclusion standpoint. For everyone in the world today, we all interact with data. We all generate data, and our lives are affected by the decisions that are made based on data. So we think it's important that undergrads today leave their program with an understanding of how data affects their lives and how to critically think about data-driven and data-informed decisions. Many of the students may not want to take coding or stats or make that their focus. So instead, we are bringing the data science to them in a class they're already taking and applying it to a field that's already relevant or interesting to them, something that they're experts in. And we're utilizing near-peer teaching, where an undergrad can be relatable in a way that a faculty member may not be. The undergrad just learned data science themselves. They remember what it's like to not know much about coding or stats, and they can share that and be sympathetic to other students. So we use a lot of what are called Jupyter notebooks. If you're not familiar, it is an open source software and a file type. And this file allows you to have text, code, images, video, all in the same place. So you can see some examples of it here. We think this is an awesome way to create a narrative experience, to tell the story of a data set, because a student can read about the data set, watch a video of how the data was collected, run a cell that runs code to load the data set, and then recreate the analysis that a real data scientist would do, whether it's training a machine learning model or calculating regression. So the process itself starts with professors or a grad student instructor. They come to us, or sometimes we will approach them and talk about the possibilities of doing a data science lesson in their classroom. Maybe they have an existing lesson that references a data set or a study or a computational theory, and we can enrich that by providing code examples and going through the whole process of how a programmer would analyze that data. With the professor, we'll work to create learning outcomes and an outline for what those materials might look like. And then it goes to a student team. So we have a wonderful team of undergraduate students, some of whom are paid and take leadership roles, and most of whom are volunteers. And they're the ones that draft the materials in close collaboration with the professors and/or GSIs. So the undergraduates will write the code, they will clean the data, they will create models, they will create visualizations, they'll write up short answer questions for the students to ponder in their discussion sections, and iteratively get feedback and incorporate that from the professor. And then finally, it's deployed in the classroom. So what I mean by that is, it might be we come in and lead a lecture or a discussion section, the professor might walk them through the materials, or the students do it as a take-home assignment. So that was a lot of logistics, and let's get to the fun stuff, which is some examples. So this class is Ethnic Studies 21 in Berkeley's American Culture series, and the professor here taught a lesson about prison realignment in California. Pretty much there was a law passed a couple years ago that changed how prison populations could be regulated. And the professor already had this wonderful teaching strategy of bringing in formerly incarcerated people to talk about their experience before and after the law went into place, about what it feels like to be in a prison cell that had 8 people when it was designed to have 2. And we then supplemented that with the data of, you've talked to 2 formerly incarcerated people, let's look at the numbers for all people that were incarcerated in California during this time. So what you're seeing on the left is comparison by gender. And on the right is an example of a widget. So this is code that our student developers write that the students in this ethnic studies class can then interact with. At the top, you can see the mouse sliding over the slider to change which institution they are looking at. It allows students who have no coding background whatsoever to interact with and explore the data and what they're seeing, and really focus on the analysis and what cool insights they can get out of it. This was also a cool project. So for the sociology class, our professor had a project that they typically did without any coding whatsoever. For this project, they had students travel along a bus line using their university free bus passes and collect data on the survey that you see at the top right. So they're looking specifically at social inequality, and they're collecting markers of social inequality for things like, how many cars are they seeing? Do they see any visibly broken windows? What kind of positive amenities, like that might be classified as churches or grocery stores, do they see? What kind of litter do they see around there? The students submit this through a Google form, and that Google form is crunched by our developer teams, who are able to load the data into a notebook and have students explore it. So the screenshot on the left, you can see that the developer team created an interactive map where students can view the photos they took of the different neighborhoods. They can see the comments that they made, and they can see the distribution of what kinds of positive or negative values were seen in which areas. And how does this correlate to census data about the average, the median income in that area, or the level of education? There's also a really rich conversation to be had here about how we are making these measures of positive or negative amenities in this area. What are we classifying, and what kinds of assumptions or biases are wrapped up in that? And by having the students collect the data themselves and using the data that they collected to do this analysis really helps get that point home, that all data came from somewhere, and the way that it was collected and analyzed makes all the difference for the decisions that are made. Finally, this example is from a letters and science class that's about scientific method. How do scientists view the world? What kinds of biases are inherent in that process? And it's something, this notebook was actually not used in this class, but we are hoping to use it in the future. So for this notebook, we got to work with text analysis. And the lesson was on seeing patterns in noise there's random noise in a lot of data sets, and it's really natural through human cognition to try to make sense of that noise in a way that might not be reflective of real life. So for this module, the students created a notebook that used real texts, in this case Metamorphosis. They also did Alice in Wonderland, and tried to find hidden messages in it using a phenomenon called the Bible code, where you take every nth letter from a text and try to view messages from another world or something that has a hidden meaning from the author. And so they were comparing randomly generated text and the hidden messages you get from that with texts that have this history and lore and superstitions around them, such as Alice in Wonderland. And so the plot that's at the top right is showing the number of types of different words that they're finding in the different types of texts, gibberish versus books, and whether there's any patterns in that. And we see that books that were made by humans tend to have similar patterns where gibberish is very, very different. At the bottom, they also found what are the least and most probable hidden words in each text, and do we see any difference for gibberish versus the human texts? So ultimately, this program has been running for a little over 2 years now, and we've gotten a couple takeaways working with so many domains and classes. First, the process must be collaborative. This is truly a meeting of the minds. In a lot of places, data science is talked about as a Venn diagram, or in some cases, the union of statistics and programming and a domain. And that's very, very true for modules. So the most successful modules are where the professors or grad students really contribute their domain knowledge to suggest hypotheses that should be explored in the data, or interesting data sets to use, or how to frame a data question to their students. On the other side, the developers have the expertise in the nitty-gritty on how to make the data show or explore the question the professor wants to pursue, and how to break it down in a way that's accessible to students who've never seen coding before. The second takeaway we learned was a focus on exploration, discovery, and interaction. We want to empower students to get their hands on data and feel like they can draw conclusions from it and have opinions about it, even if they're not an expert programmer. And using tools like Jupyter Notebooks and widgets allows them to do just that. We can abstract away a lot of the technical details and let them focus on drawing conclusions and thinking critically. We've also learned to really give the why of, why is this important? Why is this relevant? And I think modules are a great way to do that because we're connecting with material that students are already seeing. We're coming to their class, and hopefully they're already invested in that class by the time we get there. So we're able to apply data science to a realm that already has interest to them. And while we're abstracting away those technical details, we also leave space for advanced students to dig into the code, maybe test out their own hypotheses or try different approaches. So by using the Jupyter Notebooks, again, we can hide code, but that code is also available to those more advanced students. And finally, a very important component has been setting clear expectations early and reminding often. It's a really common reaction for students to freeze up when they see some of the more complex stats or coding, or even some of the simpler Python code. And that can be a really normal reaction, especially for students who are historically underrepresented in this field. So we try to go in saying that this can be really intimidating, but they are not expected to become an expert programmer in this time. We try to come in with a sense of humility of, you are the experts in this domain. We've written the code for you. Now we want you to tell us what you see. So I've linked a lot of different resources, which I encourage you to check out. You can see data science at Berkeley generally at our website. We also have a module-specific website, which will show more examples and give you the ability to launch interactive versions of these Jupyter notebooks. You can find all of our past and current modules at our GitHub. If you're not familiar with GitHub, it's a website that allows people to share and contribute to open source code projects. And finally, we have an ebook that talks about how we make modules in other classes using data science curriculum at Berkeley. So thank you so much for listening to me chat, and I think we might have time for 1 or 2 questions.
Yes. Thank you, Keeley. So a few questions. So one of the questions is that how do students respond to object-oriented programming environment of Python versus the functional programming approach of the tidyverse in R? Is it easier to teach importing modules in Python or the functional verbs of the tidyverse?
That's a good question. I think I find it's different for different topics. So the object-oriented makes intuitive sense to a bunch of new students, especially when you're getting in data science, because there's natural objects to them, like a data set or a column or a data value. So having a data frame, or as we're calling it, using our wrapper module for pandas, which is a tabular data science library, a table, there's some kind of natural functions that students can associate with that and that we can prompt students to make of what kind of features does a table have, what kind of attributes, what kinds of methods or things can you do with that table. So I think for that purpose, the object-oriented approach works pretty well. I haven't actually taught in R, so I can't say a whole lot about that. But for the functional approach, I mean, we talk a lot about how we use Python because it's designed to be pretty human readable for native English speakers. So that's an approach we take with modules a lot, is try just saying the code out loud. You can probably get some sense of what's happening if you talk it, if you speak it, even if you don't know exactly the details of the bits that are being manipulated.
Awesome. Another question we have is they've asked, how much of a data science knowledge do you require of an instructor if he or she is interested in incorporating data science into their existing curriculum? Like our Jupyter, which is difficult to master?
Good question. There is no data science experience needed. I've worked with professors who told me their last math class was in the 1970s. I've worked with professors who've come in and said, I want to put data science in my class. I don't know anything beyond that. Tell me what to do. So it's exciting that I was able to get hired as a staff member, and we're now able to devote some instructional design time, because for those professors, I can work with them to suggest some data sets or talk through their ideas and what may or may not be compatible with our teaching approach that uses Jupyter Notebook and applied Python. That, of course, takes more time and requires professors to think about their class pretty far in advance. We try to work the semester ahead of a book deployment, but it can be done.
Okay. In regards to Jupyter Notebook, some professors are asking why you choose to use Jupyter Notebook instead of something more stable versions like R Markdown, assuming one is using R, of course.
Yeah, so we like Jupyter Notebooks because there's a UX UI component. The interface we think is really, really clean and linear and narrative. And it lends it well to our approach of data science as storytelling, of we want to tell you why this is important and why this matters. We're also very spoiled at Berkeley that we have a big part of the Project Jupyter team that works right off of our campus. So Fernando Perez, who's the co-founder of IPython, is one of our data science professors. And we have an amazing Project Jupyter team that runs a Jupyter hub. So our students are able to work in the cloud. They don't have to install any software on their computer. They can use what's called NB Git puller software that will behind the scenes do a Git clone. So if you're not familiar with Jupyter or Git, basically you click a link, you see the notebook in front of you, you can start coding. And that's thanks to this Jupyter hub that runs behind the scenes. So it was a marriage of the software, which we found to be well suited for our needs, and being very spoiled by having this team on campus that runs amazing seamless infrastructure. And in terms of numbers, I think about 1,300 students saw a data science module this semester. And that's on par with our larger data science classes. Our foundational data science class is about 1,300 people.
Awesome. Okay, thank you so much, Keeley. We will be moving on to our next presenter, Professor David Harding. He's going to be presenting a little bit about a class he teaches called Sociology 88. It's a connector data science course. Professor David, would you'll be going on soon. If you could just share your screen, I'll automatically hop over.
Yes, I'm waiting for my slides to come up. There we go. Hi.
Looks like we're having a little technical difficulties. I apologize for this, guys. Virtual things just happen.
Stephen, can you not hear me?
Yes, I see you. I can hear you. Your presentation is live. Can you hear me?
Can you hear me though?
I can
hear you.
Yes, I could hear you as well.
Okay, maybe I'm having internet quality problems. So I'm going to tell everyone a little bit about this course, Sociology 88, which I piloted last semester at Berkeley in the sociology department. And the course is called Data Science for Social Impact. And so it's about combining sociology knowledge about public policy and the impact of research with practical skills to do that. So what are the goals of the course? There's some course-specific goals and some broader curricular goals. Our goals are to understand the various roles of social science research and policymaking, drawing on that existing research literature, and then applying that understanding to increase the impact of social science research. And so in order to do that, we work with the students to develop social science communication skills, some of which is writing for a public audience, so things like writing op-eds and policy briefs. And the data science part of it is doing data visualization. And there we think of data visualization as having kind of two possible roles. One role is simply as a part of your data analysis, essentially a tool that you can use as you're analyzing your data to figure out what the story is that the data is telling. And then a second role, usually later in the project, is to help you tell that story to other people. And so we kind of teach both of those skills. It's also an opportunity for students to develop data science skills in the context of a particular set of domain knowledge. And so in this course, we take on typical sociology topics like race, inequality, the criminal justice system, education, the environment. For example, there's a project on the way that pollution exposure is distributed in California and how that relates to poverty and race. In terms of the wider curriculum, this is our Berkeley Sociology's first connector course. And so the course, what that means is the course is designed to run alongside the Foundations of Data Science course that enroll, as Keeley just said, enrolls about 1,300 students a year. So it's a much smaller environment, and it allows students to connect the domain knowledge to what they're learning in that. And this is our sociology department's first one of these. Another goal is to engage first-gen students and students of color in data science through their interest in social problems and policy impact, and to start building a community around that to encourage those students to be more involved in data science, and to attract sociology majors to data science to show them what can be done with those tools, and also to attract data science students to the social sciences and its domain knowledge. So just a little bit about the course so you can understand the logistics of it. It's a lower division course, so it's designed for first and second year students. We just meet once a week for 2 hours. Started small, we'll be expanding. And depending on what material we're covering, we run the actual class session in various ways. And importantly, we have an undergrad course assistant, going back to the idea of peer learning that Keeley talked about. Content-wise, we divide it into 4 modules. The research and policy section at the beginning, then we move into policy writing, and then into data visualization, and the students work on a group project at the end of the last 4 weeks where they apply all of those skills. So they work with data, develop conclusions, visualize, write a policy brief, and then write a policy impact plan that goes with it. One thing just to know about this course, the reason it's structured this way is that because it's running alongside the foundations course, the coding and data science bit has to come mostly at the end, at the point where the students have had enough of that in the foundations course for it to be worthwhile, for it to work. So what are some of the pedagogical strategies we use in the course? First, along with the goal of drawing more and diverse students into data science, we have explicit discussions of what kind of classroom learning environment do we want to have, especially because of the topics we're discussing that we're combining with data science. We need to be very careful about those issues to make sure the environment is welcoming to everyone. We do a lot of active learning, so stopping lecture, doing think, pair, share, students working and then sharing their work with others, peer learning and teaching, and then as is the Berkeley way, we work with Jupyter Python and Jupyter notebooks and do group coding in class as a kind of lab exercise. This is just one example of how the Jupyter notebook would work. This is from our first mapping lab. So when we did visualizations, we did half plots and half mapping. So this is the third week of data science in the course. And this is just to give you a little bit of a better sense of how this works and how you can use the Jupyter notebooks to kind of scaffold the students' learning. So this is in the middle of a notebook, kind of zoomed in so you can see a little bit better. And this is where the students are working with the Folium library for mapping. And you can see this is what they're given, and that they've been given a little bit of instruction earlier in the notebook on how the library works. And here, their next step is to start to fill in some of the code on their own, try to run it, debug it, see what they produce, change the code some more to get it how they'd like. And when we're doing this mapping, we kind of divide the mapping into two kind of goals. One is understanding the data and getting the right data onto the map, and the same applies to the plots as well, getting the right data mapped, displayed clearly. And then the other is what we call design. So how do you actually then turn your visualization into one that's going to have the impact or tell the story that you want to tell? How did we go about developing the course? I worked closely with Keeley and her team, actually. The modules team also helps with course development for sections of the connector courses. And so we used that process that Keeley had on her slide. Here's some of the factors we had to kind of consider. One is that because this is a course that kind of marries the sociology and the data science, that students come in with a wide range of student experiences and skills. And this course actually had a wide range of students in terms of their experience at Cal. Some were first years and some were graduating seniors. So some students were very strong at like reading the dense conceptual material from sociology, but new to the data science. Other students, the reverse. Some students were used to a lot of writing assignments. Others were more used to coding. And so kind of walking students through building their skills from kind of different starting points was sometimes a challenge. As I said, the structure is dictated by the fact that it's a connector course. It's connected to this, what we call Berkeley Data 8, the Foundations course. We did rely heavily on the undergrad data science development team, Keeley's team, who did a great job helping us construct the notebooks. And then in order to do what we wanted to do with the data visualization, we had to go beyond the Python libraries that are taught in Data 8. Especially to do the kind of design side of visualization, we need to go to the more kind of mainstream or typically used Python libraries out in the world, rather than the data science library that's used specifically for teaching in Data 8 introductory students. So we went through this kind of iterative process. For each module, I sort of decided what the learning goals were going to be. Then we talked through what possible data sets were and what the right Python libraries were to teach, taking into account, what level of difficulty we wanted to have for the students. The development team worked on building drafts of the notebooks and then kind of iterated back and forth on how we could improve it and maximize the impact of the notebooks for the labs. And then once we were settled on what material was covered in the labs, then we could build the assignment notebooks so that they would cover the same materials in the labs. And then at that point, I would actually plan how I was going to lecture what was going to come before the notebooks. In a typical class session, I would spend the first 30 or 40 minutes lecturing about data visualization, and then we would go to the notebooks to implement some of those ideas. There's kind of a paradox in that our students always tell us they want more practical skills for the labor market, they want more research experience, but they don't always take up our research methods offerings. And so hopefully this can help bridge the typical sociology student into taking more methods. We need to serve transfer students who have often taken things like statistics before in community college and weren't planning on taking a lower div course again. Students who want to move on in the Berkeley curriculum beyond Data 8 and connector courses have math and also computer science requirements to get to the next level of data science. And then our own departmental teaching capacity means it's hard to offer these kind of courses. So we're trying to, these last 3 bullets are what we're trying to do. We're trying to build an explicit recognition of students who have focused on methodology by creating a concentration that appears on their transcripts, engaging them more through content motivation. This is the set of tools you can use to explore the content, the substantive areas you care about, and make an impact in the world, and then providing them with more opportunities for independent work, which these sort of skills prepare them to do. So I will stop there and see if there are any questions. I'll also say that I've also had a module in a different class, so I'm happy to take questions about modules if people are interested in that from the professor's perspective.
Hi, Professor. There are a few questions. I'll be starting off with the first one. Professor Heather asked, do you have a link with the general social survey and or the monitoring the future data sets?
I haven't use those myself, but that's certainly the type of data set that one could use. I actually did use the general social survey in the module that was in my class I taught in the fall. And so it was pretty easy to use those data, bring them into a Jupyter notebook. You just need to have the data in a CSV form, and then to have the students work with that as well.
Cool. And then another question is, have you had experience teaching data science in a larger class, roughly numbers more than 100? Do you have any thoughts about how to do that well?
I have not myself. This course started out very small. I hope to get to that size if I can attract more students. I think the model at Berkeley, from my understanding, is to have large lectures, but then use the existing undergrad teaching assistants to provide much smaller classroom environments for the students. So in this foundations course, for example, the students go to a lab every week and work with an undergrad teaching assistant working through a Jupyter notebook typically during that week to help prepare them for the projects and homeworks and things like that. So I think it's important to have that small environment where they can connect with a teaching assistant instructor.
Mm-hmm. A few questions regarding the course generally. One of the questions is Sociology 88 going to be offered this upcoming fall? And also, is there a math requirement for this particular course?
So I'm going to offer it again in the spring of this coming academic year for those who are interested. And the Berkeley, the kind of lower division Berkeley data science curriculum is designed to have no math requirements other than the requirements that all students have to meet to be Berkeley students in the first place. So that's the same for this course. We don't really do much in terms of needing any higher level math, not even calculus.
Okay, awesome. Thank you so much, Professor. Next, we'll be moving on to Aniket. We'll be giving a presentation about the legal studies 123 upper division course.
Sounds good. Are you able to hear me and see my screen?
Yes, we do hear you, and it seems like your voice is a little static, robotic-ish, but that might be just the Wi-Fi.
Give me 1 second to see what I can do. I might turn off my video if that helps.
Thank you.
Can you hear me a little bit better now?
A little bit better now, I think.
And then I can try to adjust as we go. All right, so hi, my name is Aniket. I am a postdoc here at Berkeley's D-Lab. I just finished my PhD last week at Berkeley Law's Jurisprudence and Social Policy program. So I'll be spending today talking to you about a course I helped develop in our undergraduate legal studies program, which was kind of data enabled in the way that we've been talking about so far. The difference between this course and some of the other ones we've discussed is that this one is sort of explicitly designed to be what we at Berkeley call an upper division course. So the ideal kind of student would probably be a junior or senior. And this is a 4-credit class, so it met for 4 hours a week with lots and lots of data science kind of every single day. So this is sort of a ramp up. And what I'll try to talk to you about is how to sort of design this kind of intermediate or advanced course within your own discipline. All right, so let's go ahead and take a look. So like I said, Legal Studies 123, Data Prediction and Law. This is what's called an upper division course for our majors, so juniors and seniors. And it builds on our Foundations of Data Science course, which is Data 8. So that's the only prerequisite that we actually required, that students have already gone through Data 8. So rather than concurrently or not have that at all, we require that they had Data 8 or some similar level of preparation. So at this point, they've already been exposed to Python. They've been exposed to a lot of core ideas within data science. And then this course basically takes those and expands upon them and deepens a lot of those topics. The other kind of major goal that we had here was to not only kind of push on data science methods wise, which we do quite a bit by introducing mapping, machine learning, and text analysis, but also to basically integrate a lot of what the data science curriculum at that point would have already been in both the technical, social, and ethical dimensions of data science. So this is really where, instead of kind of having separate courses that deal with each of these aspects, we can kind of funnel it all into one course that has students kind of work with real data sets and draw upon everything that they've learned so far in their careers at Berkeley. So just to give you a sense of the sorts of things that we covered, here was our schedule 2 years, or last spring, when we taught this course. So basically we worked with the data science education program, and Keeley was actually our development lead for this course. So her and her team developed almost all of these modules, and that was fantastic. So as you can see, we had about 2 per week, which I think still may be close to a record among the courses that we offer at Berkeley in terms of just the number of labs and modules that we have. But as you can see, we cover Folium, as Dave was mentioning, we cover some basic machine learning, and we also introduce natural language processing or text analysis. And for those of you unfamiliar with these topics, basically, these are pretty deep kind of concepts within data science. We didn't necessarily get too deep into the math, so we never required proofs, we never required anything like that, but more kind of got students to get acquainted with all the tools that were available to them and learn how to work with them in an applied way. So for example, one of our early modules or in-class labs, we had students do a heat map of crime within Berkeley. So for this, we basically had them download data from Berkeley's open data portal and visualize it using the Folium package in Python to basically see where different hotspots for crime may be. So again, the key here is that we didn't just introduce these labs and show them in a technical way how to do this mapping. We of course did that, but we also in the in-class discussions as well as the problem sets basically spent a lot of time discussing the ethical and legal dimensions of this as well. So for every single class, it was basically structured as 2 2-hour sessions per week. The first half of every class, we usually came in having read something about the use of algorithms in judicial decision making or in law more generally, and had a discussion about it. And oftentimes we would try to pair these readings with what we were doing in the lab. So then students could start to ask questions like, if crime is not kind of spatially random, if we do actually see hotspots, how do those correlate with things like race or class? And what does that mean from a legal and ethical perspective? How should police or judges be making decisions, or how should we conduct ethical research, knowing the way that geography kind of intersects with all of these things that are legally protected or legally of interest to scholars as well as policymakers. So again, integrating these kinds of dimensions of the problem was really important. It wasn't just that they learned how to map something, but also that they were able to answer real legal questions about that are kind of still relevant today by doing this sort of mapping. The other kind of unit in this class was machine learning, followed by text analysis. So for those of you who haven't seen this before, this is a confusion matrix, which is basically a really useful way to visualize how well a classification algorithm did at accurately making predictions. So again, we introduced students to these tools. In the second third of the course, we essentially taught them about regression methods. So these are going to be a whole set of machine learning methods that are going to be useful for continuous measures mainly. So for that, again, we focused a lot on crime, and we had them deal with measuring crime in San Francisco as well as New York. We had them think through what it would mean to build regression models. And then again, bringing in the ethical components of this, in our problem sets, we would require that they not only built a model, but also grappled with the ethical implications of it. So for example, one of the questions in our problem sets would be, build a machine learning model that predicts neighborhood crime in San Francisco. Now try to do it without using race as a component or using anything that correlates with race, and really force them to kind of grapple with how to do that. And oftentimes they found, oh, this is really difficult. It's not possible really to build such a machine learning model. And again, this is important because I think most people have an intuition, oh yeah, you shouldn't include race explicitly as a variable in your machine learning algorithm. That's wrong. They may even have an intuition that you shouldn't include things that correlate with race, but really forcing the students to work with real world data from San Francisco or New York's open data portals, and then forcing them to actually try to build such a model that is objective and fair was really challenging. And I think being able to go hands-on with it went beyond just kind of an intuition like, oh, I shouldn't have race as a column in my data set, and really made them deeply understand how data sets are constructed and the idea that they are human creations and filled with all sorts of biases and all sorts of decisions that go into that. So basically being able to critically consume as well as analyze that data was going to be really important. And then in the last unit, we turn to the use of legal text in data. So for this, we use the Old Bailey, which is still England's criminal court, I believe, but we basically pulled all of the text of their decisions from about 1600 until 1907 or something like that. And we basically had students try to work on their own to predict what they thought might be interesting to them and analyze these data in all sorts of different ways. And students really loved this creative freedom. We kind of gave it to them to basically decide, for the next couple problem sets, you decide how you want to construct a machine learning model and explore this data and figure out something new about it. And again, this is super exciting because basically we're using text, which is so common in law. So judicial decisions, lawyers make statements, politicians say things. When an agency makes a decision, it has to give reasons as to why it did. So law, more than a lot of other fields, has so much text that's just ripe to be used. And this area of research is still really new. So this is really empowering for our students, where I didn't have the right answers as to what's interesting about this data set or what should be explored. But the students already had enough tools at their disposal to basically look at this novel data set, go in and basically start to do something for themselves. And oftentimes their final projects or their problem sets kind of were the basis of a new finding within legal scholarship. And that's really exciting because as undergraduates, oftentimes they don't know that they have these capabilities, but there really is so much that they can do now that we're kind of bringing law in conversation with a whole new discipline, and the research is still kind of fast moving on that. So then I'll kind of say a few words about some practical tips for making a course like this. So like I said, to do something like this, we're actually pushing on quite a few advanced concepts. So I think there are courses at Berkeley for each of these things that we discussed. So geographic information systems, machine learning, and text analysis can all be taught over a semester or multiple semesters with varying levels of depth. So we basically had to think through, okay, how is it that we can teach all of these advanced concepts, but also in a way that's in conversation with our field, which is law and legal studies, but also make it kind of adequately challenging, but also open to as many people as we can. So there's a lot of balancing that we were doing here. And basically one thing that I found was effective in our teaching, so like I said, Keeley and her team put together these fantastic in-class labs that really taught the students how to work with the code and how to basically become proficient with Python. And then the problem sets, I would oftentimes design it in such a way so that there was just like one thing that was kind of changed from the way we did it in class. And that would challenge the students to then kind of figure out their own solutions to a really complex coding problem or something like that. So for example, with mapping, in the initial kind of in-class lab, we gave them a data set that just kind of worked. You could just map it with Folium's kind of built-in stuff, no problem. On the problem set, I gave them 2 data sets that they had to figure out how to merge before they could actually go ahead and map it. And that was really challenging because we didn't necessarily explicitly go over that. So a lot of them had to spend a week or 2 just trying to figure out, how do I make this work? And the reason to do this is not to be mean and make the students kind of bang their head against the wall, but rather it's to show them what it's like to really do data science, where you're confronted with a novel problem and you essentially need to figure out some way to solve it. So with a real data set, you often find a lot of different complexities, and you often need to figure out what the best thing to Google essentially in order to get to your answer. So structuring the problem sets around what will happen once they kind of graduate from Berkeley and go on to graduate school or go on to into the workforce, basically encouraging them to think how to not only identify problems, but also critically solve them on their own. The other thing I would say is that lean into integrating data science into your domain and make it as exciting as you can. So like I said, law is really ripe for being intersected with data science in all sorts of ways. What we didn't anticipate when we constructed this course is how much interest we got outside our own major. So at first we thought this would primarily be for our own legal studies students, but we found that we were getting people from EECS, so electrical engineering, computer science, physics, as well as more cognitive disciplines like political science, sociology, and history. And what we were finding is that students from all across the board, whether they had really strong technical skills and wanted to sort of add something more social scientifically oriented or more practically oriented, or whether they were coming from a social science or humanities discipline and were looking to build on their technical skills, we got a huge amount of interest from across campus. And I think that's really important because we brought in a really broad and diverse range of students who I think ordinarily may not be in the same classroom together. Otherwise, like I was kind of alluding to, at least within law, and I think this is true for most disciplines, data science is really transforming research in this space and not just teaching. And it was really amazing to basically be able to tell students, by establishing a kind of baseline foundation in data science, you're already able to do pretty cool research projects that faculty even may not be able to do. And that got them excited. It wasn't that they needed to spend years and years trying to train to do something interesting and novel and practical. It was that within the course of a semester, we were able to develop a lot of the skills necessary for them to basically find something that they were interested in. And with law, a lot of times it was very kind of locally motivated. So a lot of students studied pollution in their nearby city, and the law is kind of regulating that. Or eviction is something that a couple of my students explored in their projects. And basically we were able to do some neat stuff with it because no one else had done it before, because these tools are just so new. And then the final couple of things I definitely recommend for this kind of upper division course especially, it's important to kind of push the students to integrate both the technical and the ethical implications of what it is that they're doing. Our goals as a major for the data science major is we're producing people who not only have kind of technical competencies, but also can critically think about what it is that they're doing. They can ask good questions. They can understand the context of where data comes from. And I found it was really important to design courses like this, where it's not just that the ethics component is one course that they took along the way, but rather, and Margo will talk more about the kind of foundational course in this, but rather that the lessons from the ethics courses that they take within data science carry through their entire data science education. So again, they kind of are produced from Berkeley as holistic, well-rounded critical thinkers of data science, and don't just have a couple of technical skills that they're able to show. The final thing is that recruiting a strong teaching and content development team was critical. So me and a professor in the legal studies department, we co-developed and taught this course. And I was coming from a background with where I both have a lot of background in law as well as a lot of background in statistics, computer science. So that was very helpful in terms of being able to help students along, as well as coordinate between our development team, between the kind of more substantive readings within legal studies, and put it all together. But basically, you want to make sure that it's interdisciplinary and collaborative, because there's no one person who would be able to develop a course like this, especially at this level. So being able to recruit a strong team where people know what sorts of questions they want to ask and answer in this space, as well as a content development team that makes really nice notebooks that are instructive, that are accessible, and that really get the point across of what it is that you're trying to teach. These are going to be really key to the success of this kind of course, because again, we are ramping up from kind of the introductory level to the intermediate and advanced level, and the more kind of expertise that you have going behind the development of this kind of course, the better off you'll be. All right, so with that, I will leave some time for some questions. Do we have any?
Yes, just a few. So one of the questions is, students have to learn and widgets fairly quickly in order to do this data analysis project in a course. What materials do they need to provide them, or do professors need to provide the students in order to do that? Do the students have to take an introductory Python course as a prerequisite?
Yeah, so I think I missed something there. So you asked what resources do you need to provide and what are the prerequisites?
Yes.
Yeah, so I'll start with the prerequisites. So for this course, we basically require Data 8, which is our Foundations of Data Science course. So you should have already had one semester of data science, essentially, before they came to our course. In practice, the more that they had, so if they took some connectors or something like that beforehand, they were better off. And of course, if you were coming from a computer science background, then you were really well off in terms of the technical preparation for a course like this. But yeah, at a minimum, Data 8 was good. With the expectation that if you're coming in with less preparation, you're going to have to do more work over the course of the semester. And again, I found that the students were more than willing to do this. They were very excited and interested here. So as long as they came in with that baseline, whoever needed to kind of catch up did that extra work to do so. And that worked out quite well. In terms of resources that we provided, so me being the TA was a big resource. I would hold probably 3 or 4 hours of office hours each week to go over problem sets. I would be available to kind of debug code and things like that as well. So that was really important, that they felt they had a safe kind of space to come to for that. In our second year of teaching this course, we also had connector assistants. So this is a program also set up by the Data Science Education Program, where we basically have undergraduates who help with the course development or help with the course facilitation as well. So 2 of our students from the first year that we did this came back as connector assistants in our second year. And that was helpful because they also provided additional office hours and additional help to anyone who kind of needed it on the kind of coding side of things. And besides that, we made sure to give as many resources as we could in terms of readings, access to Medium, blog posts, and things like that in general. So yeah, the key thing though is that the students have someone to come to with their problems, and ideally multiple people to come to, and hopefully that also facilitates a lot of group work as well.
Okay, thank you. So now we're going to be moving on to our next speaker. Professor Margo, would you be ready to share your screen? Awesome.
Do you see it?
Yes.
Great. And you can hear me, you can see me.
Yes, we will be. So, yeah, we see your entire screen. as well as your camera view.
Great. Thank you. Thank you, Stephen. Thanks very much for inviting me. What's really been exciting about this conversation so far is the way that it tries to bring together the social sciences and data sciences, or the technical and the social aspects of university education together, and especially doing so in this moment where I think there's critical need for this as we think about what education will look like after we've survived the pandemic. I've been observing over the course of our conversation that we kind of have been following a really nice progression. We began by Stephen and Daniel inviting us to think about data science within the social sciences, and we've moved forward to Aniket's presentation, which really in very concrete and beautiful ways brought together understanding of a domain emphasis with data science in a way that's kind of goes beyond the utility of law as a domain emphasis only, and with the kind of the normative and social science insights about that go beyond law as a place in which data science is embedded. So my place in this, I think, is to continue this progression. I'm a social scientist, and my work at Berkeley in relation to data science has been to integrate social science into and for data science. So here, again, social science serves not as a domain of application, but as structured ways of knowing that actually train data scientists to become more critical thinking about their work and about their role in the world. So I'll dive right in with an example to begin my conversation about the human context and ethics and what that means and how we teach it and practice it at Berkeley. The example, the image is probably familiar to you. This is an image of the dashboard from Johns Hopkins University of COVID cases around the world, taken already a few months ago, so it's dated in its numbers. But we begin our class, Data 104, Human Context and Ethics of Data, with introducing students to the concept of the so-called datafied world, a world that we here on this call certainly all partake in, where data is ubiquitous and informs how we know ourselves as individuals, how we know the world around us, and how we live our lives as individuals and collectives. And I think this image, sadly so familiar to us today, is a product and a representation of this datafied world. It's impossible to think about the way we live this moment from data, right? The way in which we know about the virus, its symptoms, keep track of its spread, determine what are appropriate social policies and when to and how to enact them, how we experience day-to-day life, like working and learning from home, how we do our basic necessities like shopping with the help of delivery companies like Amazon and DoorDash, or even the normative dimensions of this moment, how we motivate ourselves and our communities to perform particular actions while keeping an eye on these powerful visualizations of the curve and the imperative to quote unquote flatten it. Right, so our experience of the present is profoundly shaped by data technologies, and it's at the same time also not a brand new phenomenon. The ways in which we live this moment have been shaped by decades of shifts in science and culture, imaginaries of technological disruption, transformations to labor and gender roles that have have a long history, and visions of self-improvement and what is a good life. So to study the human context and ethics of data is to learn about these diverse dimensions of the human condition, the institutional, individual, cultural, historic, that influence and are influenced by data technologies. This is what we talk about when we say human context. It's the ways in which data is embedded in histories and institutions, and the way that the data technologies and data science equally transform the human context of our lives. It also means an examination of the aims, imaginations, and normative ideals, ideas of what are desirable futures that societies pursue with data science and technology, and how these are shaped and reshaped by technology. So here is the concept of ethics and what we think about when we mean ethics. Ethics not just as right and wrong, good and bad, but those aspirations and aims that are informed by technology. In the human context and ethics program at Berkeley, we train students with we give students social science tools to provide them with structured ways of thinking about this datafied world. So we're not just raising awareness about issues like bias or fairness or privacy, but really giving them insight and knowledge from the social sciences translated in an approachable and understandable way to know how to be able to think about the present, know how we got here, think about how it informs where we're going, and help them to act, help them to shape the moment as technology designers, consumers, and citizens. So there is a profound place for the interpretive social sciences and humanities in the data science education project. We have the Division of Computing, Data Science, and Society, as we have in Berkeley, has the society as a core piece of what it's doing. And you might have already recognized that in what I've been talking, I've been using and referring to history, to ethics and philosophy. My own background is in the field of science, technology, and society, and in history of science and technology. So there's a profound place for humanists and social scientists in the project of data science education. Now, this diagram, someone mentioned Venn diagrams about what data science is. I think at Berkeley, it's interesting to point out that it has this human context and ethics kind of corner. We like to think of this as the four-chambered heart. So data science brings together statistics, computing, domain knowledge, which could very well be social sciences, and introducing statistics and computing into social sociology, for instance, or law as a domain is really profound and gives new insights for that field, as well as helps to learn data science and practice. But there's also this human context and ethics piece, which is separate from social sciences as a domain knowledge. We offer and teach human context and ethics, or HCE as we call it at Berkeley, in two forms. We offer it in a dedicated class, or it's actually a set of dedicated classes that are required of students students have a requirement in the data science major and minor to take one of these standalone human context and ethics classes. I'll give you an example of the one that I designed and co-teach in a minute. And we also have, as Aniket really beautifully illustrated, have human context and ethics integrated in technical classes and domain classes that use data science, so that students, as Aniket again said, see this as an integral part of what it means to be a data scientist and to practice this science. So let me tell you first a little bit about the dedicated piece. So the Data 104 C course, which I co-designed and have been co-teaching for the last 5 semesters. Interestingly, our first semester of offering this course was in the spring of 2018, and in May of that year, in April of that year, as we were nicely humming along halfway through the semester, Cambridge Analytica happened. So, you know, that was a nice marker for the beginning and need for this kind of these kind of courses and conversations. Our Data 104 course has 8 core units, and I thought it might be helpful to provide you an overview of the kinds of things we talk about and learn in this course. If you would like to see the syllabus, it's available as a Google Doc, and we'll give you readings, some assignments, information, and you're welcome to reach out to me for other things like rubrics, lecture slides, or just conversations about these various topics. Everything we have is open. So the class covers, as I suggested to you already, this begins with this idea of the datafied world. So understanding the historical dynamics that have led to the present moment and the role of data in the world today. Understanding data science as a field and what it emerges from and out of, and thinking abstractly about data. What makes data? What is this relation to older ways of collecting, analyzing information? We move into a unit on responsible data, which talks about the institutions and policies that exist to govern scientific work with data and to govern corporate practices as well. And we think about the challenges that our present reality of the datafied world presents to these institutions and frameworks. And we invent with the help of philosophy and applied philosophy, we invent an approach to thinking about ethics that is very dynamic and in conversation with science, technology, and society. A really important part of the datafied world is its role in the formation of the person and interaction with the notions of the self, questions about privacy, and why does it matter that data comes from individual persons? That's so much of the data we have and collect comes from the individual and traces back to the individual. We study the ways in which data is collected from individuals and for what purposes, how it's valued and valorized, and what happens to identity and our understandings of self in the presence of ubiquitous data analytics. But of course, the person, individual, is not possible to abstract from the broader social and collective elements of life. So collective life, particularly the historical co-emergence of statistics as a field with the formation of the nation state, and the history of how data has been used through the centuries to govern populations, is very helpful for reflecting on our present moment. In which, once again, all kinds of life in the city, policing, surveillance in public and private spaces is done with and with data. So the role of governance is crucial. Next comes our unit on data and democracy, which really closely tracks transformations in the public sphere through conversations about content moderation, persuasion and argument, visualizations, and their power. To conversations about the law and the formation and transformation of constitutional orders and how technologies govern similarly and differently from the way that law governs human relationships. Of course, elections is another important topic in this unit, especially as we're coming on to fall 2020. Scientific research is a set of conversations about transformations in the disciplines, the kinds that we are having today here in this talk. What's happened with science? What does it mean that science is changing? How is science changing? Open science and reproducibility also. The second to last unit is about machines and industry. Here we talk about labor and the Silicon Valley, the history of the valley, and shaping the way that we live and experience the moment of data and experience work in corporations that work and operate with data. Questions of the environment are here as well. And finally, we conclude with our ethos of making, which ties together ethics and pursuits of the good life with data science practices and recognition, trying to teach students to see their work as data science practitioners to be broadly about making and constructing worlds, not just narrow technical applications of technological use. So that's a snapshot of the course. And one thing that we've kind of pull out of this course, and in our program we teach it to students in the class, but we also pull it out as a set of tools that we integrate into technical education at Berkeley, is what we call the Human Context and Ethics Toolkit. This is a unique approach of Berkeley to the teaching of the social and ethical components of data science. The toolkit, as you can see, is a set of concepts and methods from science and technology studies and history to build understanding about the datafied world. So helping students to identify where human power structures and value choices get built into technical work, and empowering them to discover how, when, and where they can responsibly and effectively intervene in the world. So this toolkit is a kind of our bridge from this standalone data science human context and ethics class, where we have the luxury of spending a whole semester in these conversations about the social dimensions, to courses like Data 100, which is an upper division UC Berkeley course called Principles and Techniques of Data Science, focused on regression, linear logistic regression, feature engineering, and a lot of other data science techniques. We embed this exercises, homeworks, Jupyter Notebook homeworks, lectures, discussion questions that utilize this toolkit and teach some of the most relevant tools for various techniques and data science data set examples that the students are working with into classes like Data 100, classes like Stat 102, which is the decision making and data science course, classes like CS 189, which is a Berkeley machine learning course. So it's our way of as Aniket illustrated and argued for very well, of blending really integrating within one course and within the knowledge, within the mind of the data science major, these radically different ways of seeing the world and acting in the world that are data science and social science. So I see that we are relatively short on time, and I want to make sure that we wrap up. So I will skip my examples of how we actually use the toolkit to teach in Data 100 and in these other courses, I'm happy to walk through these and other ones that might be more relevant to you in private conversation later, so send me an email. We have a lot of examples and some resources already on our website. I would just leave you with a few key takeaways. So first is that there are so many important and necessary opportunities for partnership between social sciences, humanities, and data science. It's outside even the use of social sciences as a domain of application. There's a really important role to humanists to provide students that structured understanding of what life in the datafied world means. There's also an importance that when you're working in the space of being a social scientist within a technical major or technical community, that your role is really to be building infrastructures, right? What others can teach the course themselves. I think Keeley's work is a beautiful example of someone who builds infrastructure that then is deployed and others can use on their own. So think about, therefore, institutionalizing, maintaining, making things sustainable, repairing things that they go wrong. These are not just one-off lectures. They're really kind of ways to engage and help others do what you do. And finally, aim for your work as a social scientist working in a human context and ethics space to be actually beyond data science. So clearly has a reason for serving data science majors, data science minors, students who are trained and technically, but it also has a tremendous benefit to general education, because you cannot really be a fully adequately university trained student of the present without understanding the place of the data science in the world. So it's really a service to general education and empowers everybody along the way. So I conclude with just some links to where you can find resources. Contact me if you'd like anything in particular or have questions, and point you to that something that Stephen will present in a moment, which is about a panel that we will have on human context and ethics training and education at the national workshop coming up in June.
Awesome. Thank you so much, Professor. We will be moving your Q&A towards the end of the webinar because our final presenter needs to go at 3:30, a little bit over. So our next presenter is Suhem. He is in charge of, or he is working with academic research at Twitter. So his presentation will be about how professors can use Twitter data products, APIs, to teach data science within your course. So we'll have him. Awesome. We're live now.
Oh, just give me 1 second. Are you able to see my presentation?
Yes, we are looking at your Google Slides.
All right, awesome. Yeah, firstly, thanks for having me on this webinar. I'm super excited to be here. And oops, let me just switch my slides. Yeah, as Stephen mentioned, my name is Suhem, and I'm a developer advocate for academic research at Twitter. That means I want to work with professors, students, research institutes that use Twitter data for doing their research. And I'm super excited to be here because Twitter data is Twitter is one of the few companies that's actually providing real-time data that professors and students can use in their studies. And so I wanted to talk a little bit about how you can get started. So first, I'll talk about a little bit about what Twitter data is and how Twitter data is specifically used in academia, and also particularly for teaching data science 101 kind of classes. And then we talk about what some challenges and opportunities are there in this space, and also walk through how students and professors can get started, and we'll discuss some resources at the end. So firstly, what is Twitter data, right? So Twitter data is anything that's made available publicly via our APIs. It's basically what's being talked about on the internet by millions of active daily users in a bunch of different languages. It's also used by people in like humanities, as well as in computer science, social sciences, and so on, to study what's happening on Twitter and in the general public. Now, specifically for teaching in academia, there are a few challenges and opportunities around using of Twitter data, right? Specifically for people that don't come from traditional computer science background, for example. So for example, the Twitter data right now is available using APIs, and for many people that are from non-CS backgrounds, they might basically struggle with understanding what an API is. How do I understand the different API methods? How do I like authenticate and things like that in order to get that data? And then similarly, like even within authentication, like many students might not even know what OAuth is, for example, in terms of authentication and things like that. So generally, the way that professors use Twitter data in their coursework is either they'll have a prerequisite in order to take that class, right? So some will have a prerequisite that, okay, you should know how to code in Python or R, things like that. Or some will do a boot camp similar to what Bit Project does, where they'll introduce you to enough programming that you're able to use Twitter data in your courses and in your assignments and studies. And obviously, you don't have to be like a really good programmer, or like you don't need to have a lot of like CS courses under your belt. You should just know enough programming in order to be able to use these APIs. So for example, if you know how to use basic Python or R, then you can just use some existing libraries in order to quickly get started and get the data that you need in order to do your research or even your assignments and things like that. So you don't have to. The good thing about these existing libraries in these languages is that you actually don't have to worry about the underlying API calls, authentication mechanism, and things like that. All you need to do is create a Twitter app, and once you've done that, you can basically get your API keys and get going. And also Twitter now makes available a lot of code samples that are essentially just plug and play. And I can give an example of that in just a second, but we're making it easy for you that we want to make sure that you spend as little time on coding as possible and focus more on your research and getting to the data that you need. And so for that, we have a lot of code samples available as well that you can just use. And obviously, there are third-party libraries that let you use Twitter APIs. So for example, if you use R, there are libraries like RTweet, or if you use Python, there are libraries like Tweepy that let you quickly connect to some of this data. So before we get into some of the examples of things that can be taught, what are some of the things that people study, right? So some people might study things like misinformation, or even right now in the times of like COVID-19, people might want to get data around this to study outbreak of disease and things like that. People study crisis response, right? So for example, an example is the Hurricane Harvey. When there's the Hurricane Harvey, how were people using Twitter as a crisis response tool? Then also detecting real-time events and things like that. That's actually the value, because Twitter provides two APIs specifically for getting. One is for like getting real-time data. So as conversations are being had on Twitter, you can get data in real time using like filtered stream and sample stream endpoints. And then also you can get some historical data, so you can go back and study things that may have happened in the past. So the Hurricane Harvey would be an example for that. And then for professors, obviously, because once you know that your students have enough programming experience to be able to simply use an existing library, right, like the RTweet and Tweepy that I mentioned, then you can actually build your course around specific things that you want to teach. So maybe you want to do data wrangling. So you want to show people or your students, how do you get the data? How do you clean your data set in order to be able to do some meaningful research with it? Exploratory analysis, how do you do that? And then some people earlier also mentioned like classification, right? So you want to classify tweet data into like whether this tweet is maybe like has a positive sentiment, negative sentiment, and things like that, and do things like your confusion matrix and so on. People also use it for topic modeling, and also if you want to teach visualizations, right? So a lot of data science 101 classes will teach you how to do visualization with something like the ggplot2 thing or matplotlib and things like that. And those are pretty easy to use with Twitter data. So if you're using an underlying library, then obviously you can get to that fairly quickly, right? So the steps that you need in order to get Twitter data. So first thing is that you should keep in mind developer.twitter.com should be like your go-to place. So in order to access Twitter data, you first need to have a developer account so that we know that we trust you. You're a student and a professor at your university. In your application, you should obviously make a note of that so that we know who you are and why you want to use Twitter APIs. And then you go and create what's called a Twitter app, which will give you your API keys. And once you have those keys, all you need to do is get the code samples from developer.twitter.com, and I'll show that in just a second. Or the other option is you use an existing library, and then you plug those keys in there, and then you're good to go, right? Before going into the resources, I'll show you the developer.twitter.com that I was talking about. So here, if you go to Labs, so Labs is the new endpoints that Twitter is launching as part of our next gen platform. So if you go to Docs here, you will be able to see a lot of different endpoints that we make available. So for example, filtered stream will basically let you access the data in real time by adding some filtering rules. So for example, here, a person saying that give me all tweets that have images and contain a certain keyword, right? And what you can then do is you can simply copy this and run it inside of your IDE. So here is an example that I have. I basically copy the code here. I just replace my keys. That's it. That's the only thing that's different. I'll get my own keys from developer.twitter.com once I create an app. And then, yeah, basically, if I want to change the rules here, I can change the rules by saying that, OK, get me all tweets about a certain topic, add additional operators. We have a lot of different operators that let you filter for this data as well. And then here you can see now, based on the filtering criteria that I set up, it'll start giving me the tweets. And then obviously, once you get the tweet data, I'm obviously just printing the tweet ID, but you'll actually get the tweet text and things like that you can then use to do things like sentiment analysis. You can build your own classifier model. You can do visualization and things like that. So some resources that I pointed out here. The key one that you need to remember is developer.twitter.com, because that's where you're going to go and apply for a developer account. And then also you'll have access to our code samples. Then there are a couple of other things. TweeP is a library in Python that gives you access to the APIs without having to worry about making the actual calls yourself. And if you're obviously using R, the equivalent of that is RTweet that you can use. And RTweet will give you access to the same data, but in R. And then we have certain specific information for professors that are trying to use Twitter data in their classroom, how they can apply for access as well. If you go to use cases on developer.twitter.com, there's a tab for academic research, which gives you different products that that Twitter has that you can use for academic research and even teaching. And then also we have helpful tools and resources that tell you a bunch of different resources for visualization analysis and things like that that's available. So if you guys have any questions, you can obviously always reach out to me on Twitter, specifically if you are a professor who's interested in teaching with Twitter data in your class and you're not sure where to get started, or you need any assistance or help in order to identify how you can get access, or things like how can I which library makes more sense? Should I be using a certain, like a Jupyter notebook and things like that? I'm more than happy to help provide guidance on that. And obviously, we also have twittercommunity.com. On that, we have specific forums for academic research, where people also discuss things like best practices for teaching Twitter data in a classroom setup. So yeah, feel free to reach out. And do check out developer.twitter.com, apply for access, and try some of our code samples to get started quickly.
Awesome. Okay, thank you so much. Suhem, or that kind of, sorry about that. Still trying to figure out how to present my screen myself. Oops. So thank you everyone for coming. That essentially concludes our webinar. Professor Margo also had to go. She had another 3:30 schedule, but she is very open for everyone to email her. Her email is attached on the public Google Slides. You could email her with any questions that you may have that she unfortunately didn't get the chance to answer. In regards to the last resource we were providing for you guys, so UC Berkeley, and supported by Microsoft, they're holding a National Workshop on Data Science Education. So here they'll be going over a lot of the different beginner courses, such as Data 8 that is offered at Berkeley, as well as the connected courses that Professor David Harding was part of and taught this past semester. And as well as Professor Margo will be speaking at this panel, kind of giving a more in-depth overview of her course, Data 104, Human Context and Ethics in Data. So thank you everybody for coming to our webinar. This concludes the webinar, and we are going to be sending you a feedback email. So if you would be willing and if you're available, please send us some feedback regarding things regarding this webinar. And thank you so much.
Great, thank you, Stephen. And I'm going to share one last thing. So, please go ahead and give the BIT project team any feedback that you can. They would really appreciate it. And I'd like to thank everyone again for attending this live event with BIT Project and Microsoft here. We do have a couple more things coming up. For example, the Data Science Education Week in June. But next week on Monday, we do have a class on using Microsoft's facial recognition API within Azure. So if you'd like to attend that, go ahead and just go to ak.ms/svreact, and you'll be attending a class with the Microsoft Reactor group, which is kind of like our developer and student hub. So again, thank you everyone, and we really appreciate it.